Hello and welcome if you're watching this in the future. Today will be another laid back stream where I'll toy around with fixing different stuff. But first, let me just get set up here. I'll do some adjustments here in terms of the stream setup. I need to fix the chat. As always, let's see, did I unlock it? Yeah, I did. There we go. Did YouTube glitch out or something? Well, I don't hope so, at least. YouTube might have glitched out a bit. Hopefully everything runs as intended. All right. So, during the last stream, a guy named Look Into suggested one of our viewers on the channel that he used a orthographic matrix in terms of translating from screen space into normalized device coordinates and potentially back. And I told him and Mr. Yes that it wasn't needed, which is strictly true, but it might be worthwhile to do anyway. Because you can actually let the GPU do a lot of your math for your, or maybe not a lot of it, but at least some of it. Which means that we can cache different information. For instance, we could cache the font information here. We would only need to pre-calculate the UV width and height. And basically we could just pass screen space coordinates to our rendering pipeline, and inside the rendering pipeline the appropriate matrix would be used to calculate the UI elements in screen space. So yeah, since our UI is taking up a bit of the CPU time, I figured, well, the GPU would probably do it way better anyway, since it's running in parallel on a lot of different stuff, including vertices and pixels. So yeah, let's use that piece of hardware to do something useful. So therefore, we're gonna implement, hopefully today, maybe tomorrow, a way to do GPU-based rendering slash screen space transformation, orthographic transformation to save some CPU time. I also copied and pasted this from the level editor over to the UI because, well, we need to fix some stuff here. Off stream yesterday, I had a bit more time, so I actually added a border to the text itself. I also changed the renderer a bit, meaning that yeah, we now are able to actually render the border of the text. Um, so yeah, that changed. Um, we might play around with the actual font and the looks of everything here. I can even see a bit of vibrating here. Yeah, maybe that will be fixed whenever we fix everything in terms of doing a GPU-based rendering for this, or rather a GPU translation for this. Okay, this doesn't flicker as much, does it? I wonder what that weird artifact is. Oh well. But yeah, there's definitely improvements to be made to all of this. Yeah, but right now I'm not gonna spend time doing it because, as I've mentioned, I'll redo a bit of the rendering anyway to implement that suggestion from the aforementioned viewer. Uh, since, yeah, although it was not necessary per se, it was probably more optimal to do it. Yeah, so we have added some bordering to our text. Right now we have created some, yeah. Yeah, we'll have to play around with this. Anyway, the part of the code that would be more optimized is obviously the render UI code here. We could eliminate a lot of these calculations for each character. We could pre-cache some character information, and that would speed up our processing on the CPU side here. We could also get rid of this. Yeah, everything would be way faster, I think. So let's do that as a second priority, I guess, today. Excuse me. Yeah, so what I need to do, let's move this back to the level editor. Okay, and let's see. So we want to do some nice features. Let's see if we get to it today. But other than that, I'll do some cleanup of the different functions for our UI. We need to clean up text, buttons, list box, and list box item. because the way that, oh, and of course, text field. Because the way that we calculate the sizes are not that great. We should probably do some different kind of method. So let's see, today slash tomorrow goals. Clean up the functions here. Hello, man. Welcome. Long time no see. Better sizing. It's going okay. How about your project? And we will do the GPU transformation to NDC for UI elements and text pre-cache of a vertex data. So this is the state of the UI right now. I have a level editor here in the making where we can add a object. As you can see here, we can click that object. No, I don't have a collider for it. So let's see. Okay, when oh, I also need to fix that bug. So whenever we change we can change the mesh and we can delete the object and so forth. Yeah, exactly. It's all right. We also need to fix some bugs here. Check for mouse hover on UI in terms of whole raycasting. Okay, so I'll start working on some of this. Since it needs to be done, so I hopefully soon can be done with this level editor stuff here. Okay. Let's simply start from the top and do the first UI function here. So we have a button. The way that we compute the button. Let's do -1. Right now we don't use this. Hmm. Um, Hello, Rengoku. OpenGL, you don't have to try to help me because I won't be needing the advice. So yeah. How are you doing, Rengoku? Thank you. Yeah, I think things have been going quite all right in that regard lately. How are you doing? I'm doing pretty all right. I've just been at work and doing this stuff here for now. Let's see. So we're working on this. So we could do something like um, if the okay. So inside this calculate text size here, we iterate over it for now. So if the R size here, X, and R size, Y, we want to override, else we want to calculate from the label size. And we'll create a vec2 size. And we can create a bounding value for the text size here. So if the text size, let's also pre-allocate that. So we set the text size, and this is of course the case where let's see, we use R size X here. This way, when we do a predefined size, we use that as the clipping rect of our text. Otherwise, we use the whole width. And maybe we actually don't need the size itself. And we could still use, this is a testing value. So for now, this will restrict the text size and set a predefined size. And we will still cut our text in terms of when it's out of bounds. So inside our level system here, where we do the UI stuff, we could try setting a toggle debug info button here, where we initialize the size as maybe 20 pixels wide and 10, or rather one high. Let's see. Let's create it instead. I mean, button label. Oh, I'm doing it outside the correct scope. That is why. Or rather, not scope, the Wrong parenthesis. So let's see. Okay, we get a really small button with no text. But if we increase the width here, 200 pixels, we get all of it. But it doesn't overwrite, so it right now just clamps to whatever size the text has. If text size x lower than r size x, well, this doesn't make any sense. We only want the index of bounds here. We don't care about the return value. We simply set the text size here to our R size because we only want to know how our text should be altered. We don't care about the actual size. As you can see here now, we have a button, but the text gets drawn anyway. Yeah, let's fix that bug. Maybe it doesn't clamp especially great at the line height. Well, okay, we will set it, but we will update the X component here, meaning that we will use the Y for the height of the text. So even though we specify a smaller rect than the actual text, we can only render a button that is at least the text size of height. So we can render something that is bigger, but let's see. Toggle, for instance. We could make something that is way bigger here, and everything should be quite all right. Yeah. I don't need it right now. Let's see. Okay, it doesn't overwrite, I think. So let's debug that. Yeah, of course, but that's not needed to. Oh, wait a minute. We do a check here. If yeah, probably. If it's lower than the R size here, we simply set the text size Y to the R size Y. Yeah, so now we can expand our button downwards. Since we only have scrolling downwards, we will only allow that kind of overflow or exaggeration of the size. And otherwise, we will just let the text size decide the other parts of the UI. Okay. Just a second. Someone was at the door. So I needed to just see who it was. Okay. Let's see the... Yeah, I think that is all right. We do like that. If it's visible, we create it. Yeah, I think that works fine. That works fine. Okay. Our list box here is hard-coded. That's not what we want. Number of items. Let's see, let's change this. So we have the number of items. I'm not sure that we want this pre-specification, but anyway. Let's do a int in terms of items shown. Or do we want a float? We could do a float. I can't access it like that. So instead here, we will do the items shown. This is our scroll bar. If our size, let's see, x, y, else we do something like this. And let's do okay, and then inside of this function, we need to specify how many objects we want to be shown. 5 items. Let's add another. That seems all right. That seems all right. Maybe if we only shown 3. Yeah, that's still fine. Okay. Let's do 5 here. Okay, so we can potentially overwrite the size, otherwise we just use the text size as the item size. That would be fine for now. Okay, I think the next thing I want to clean up a bit is the text field thing, because this kind of like looks not so nice. I mean, yeah, the sizes are kind of like off, and yeah, I would also lack some functionality in terms of um, doing what do you call it? Some inlining, no, not inlining, making these appear on the same line. And I also need to fix this handle system eventually, especially when we get enough text fields, but I'll probably do that during the weekend. Uh, let's see. I was just checking out some stuff. All right. So the text field here gets a label size and a field size itself. So that is actually hard coded. We could calculate the field size of, let's see, if we take our font, which one is the widest? Width 29 seems like 30 maybe. Seems like a fairly wide character. Um, and let's see. When I pass in the information here, when I create a text field, I ask for the string length. Our buffer itself is 0, but we write the mesh value here. So we could do something like whatever value we copy into our buffer, we let that decide. Our current buffer size. Hello, buddy. How are you? We could store some information. Yeah, that sounds great. I actually thought about what the guy called Look Into suggested yesterday, and even though it's not needed, I decided that I, due to performance reasons, wanted to implement something like what he talked about. So I'll redo my rendering, hopefully today, maybe tomorrow, of my UI elements, and I'll let the shaders convert from screen space into uh, normalized device coordinates for me, since it's faster to let the GPU do all the calculations each frame, since it's highly multi-threaded. So we can save some CPU time by letting the GPU do it for us instead. So I'll actually implement the orthographic projection matrix and um, give a not a tour. All right. You can watch along or decide what you want to do, but I'll definitely show how to implement something like that where you don't need to translate between normalized device coordinates and screen space coordinates. Everything will just be in screen space coordinates, and the shader will handle everything for you. Um, yeah, but feel free to use that at least. Anyway, so our field size here, I will, if not today, then I'll make it tomorrow. That's for certain. All right, so let's see. Our field size here should be, well, if we know that our max character might be 30 pixels wide, um, we could do something like text buffer size here. And our height could be something like text size dot y. Let's see how that works, and let me do hot reloading so I can make changes without reloading everything all the time. So now our text field does seem a bit more uh, um, reasonable. Well, now our cursor here gets messed up, but um, let's see. Uh, our awesome bullet here. I do think the text fields did get a bit better. Um, the labels are still a bit messed up, I think. Um, we add the field size. What happens if we only do one here? Well, that's the same size here. Is a character really potentially 30? Or is it, oh, maybe it's mapped in terms of the yeah, it's of course the pixel stuff. Yeah, I'll definitely redo the font work here again and again whenever uh, whenever we fix that. Okay, but anyway, let's do a conditional here. Text buffer size larger than our amount. Let's do this const expression here. It will be fast because it's a const expression where we do, if it's bigger, we do the amount of visible characters, and otherwise we use the text buffer size. Okay. Let's see our and for some reason, yeah. Let's see. Yeah, then it gets really weird. There's definitely something about these translations here that hopefully will get fixed when we implement the other stuff. Okay. Yeah, actually, I think I should probably change the way that the text is rendered now, because it will also potentially change our output here. So I have my vertex shader here for my UI, and if I remember correctly, I also have a constant buffer somewhere in my root signature. Let's see. Renderer, DirectX, pipeline, root signature. Yeah, so the first, oh, there are, oh, it's ranges. So the first uh, buffer is actually the view projection matrix buffer. I think this should be vertex shader, by the way, because yeah, this might also be pixel. Let's see if we have crashes. If I change this, I might have crashes. Yeah, that's all shaders. Yeah. Yeah, okay. Let's not change that for now. I'll work out a better root signature whenever this project kind of like gets to a proper level. Anyway, uh, so we have a constant buffer slot there. We have one more right here. We probably won't be needing the view projection matrix, so we could just use the first slot inside our shader here. Let's see our shaders, pass data. Let's copy that binding inside our shader. And let's do a ortho mat matrix. Transform. That is probably fine. Let's see. We should be all right. Yeah. So what we can do now is inside our renderer, we can actually create a slot for this um, orthographic transform. Let's see, whenever we initialize, we create our mat data, material buffers. Let's see, we actually don't need to store it anywhere, but I would like to upload it on the GPU. So whenever we create our, we could do it in here. Basically, we will be creating a static object of sorts. We will do something like this allocation here. Yeah, okay. Create mesh data, create mat data. Well, do we really want a okay, we want a function void create static buffers. And our initialize, we'll call it. Just for now. Could be moved outside of the system dependencies. Dependencies. There we go. So we will simply do we have any data structures that are able to hold our information here? Transform matrix, GXE, G matrix. Well, we don't need a G matrix for this. We can use a float 4x4. Transform. Is it? It's the aligned one, is it? Yeah, it's the aligned one. Okay. So this holds more complex object data. This is just a transform matrix. Let's see, does this say contain a union? No, it doesn't. But we will be fine. We can use the constructor to create our matrix. It only needs to be created once inside our renderer here. We want a transform matrix, temp maps, where we will create a orthographic projection matrix. Let's see. Let's see. Just a second. So our temp matrix here will have a transform that will contain let's see, how is it aligned? It's aligned D0. The first component is the columns, meaning that if we can specify it in row major order in the constructor. Yeah. So our first component here will be, let's do some pre-computation actually. So, well, we don't need any information here. So let's do the first one where we divide by our width. Don't I store the information here on the renderer m width? That I do. Oh, wait a minute. I'm in the wrong place. OpenGL, no, my system actually uses row column major for the shaders. So, but as I've mentioned, I don't need your advice, but thank you. You don't need to type it out in the chat. I do not have a problem by figuring out myself what to do. Let's see. And let's cast it as a float. Oh, wait a minute. Uh, okay. The constructor doesn't. Oh, maybe if I do something like this, I'll be better off. Yeah. Exactly. Now we're good. And let's do our height. And this will just be our width. Or rather, wait a minute, this will just be 1.5, I think, and 1. Uh, uh, there we go. And let's see. We will static constant buffer allocator. We will allocate. We won't be needing the ID, although we could alloc. And we will tell our linear buffer uploader here. Linear buffer, did I call it that? Yeah. Okay. Q upload. The destination should be our. Well, do we actually allocate these on the what do you call it? Yeah, we actually upload it to dynamic memory. Well, that's not great. We will fix that in the future. Get resource here. And the offset will be our alloc times utils. Calculate constant buffer alignment from our size of transform matrix here. And we will use our temp mat here. And the size of our transform matrix here. All right, so whenever we initialize our program, we will allocate a what do you call it? Allocate a orthographic view projection matrix. All right. Created the orthographic matrix at allocation number, and then our alloc here. So we should see our console print out that the static buffers. Yeah, of course we need to offset everything, but let's see. 0 is the allocation. All right. Let's see in our draw calls here. At static, this should be allocated as is, but I think the way that we bind our stuff down here, yeah, whenever we That's our mesh data. Material buffers, blah, blah, blah. Let's see what is actually happening here. Yeah. For some reason, our draw call doesn't seem to be correct, is it? So let's see. Let's see if I add one to this. Well, nope. If I minus one, no. No, 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 no. Well, okay. Do I actually remove, update? Oh, this is... Ah, that is why. So this needs to be offset by 1. Actually, this needs to be fixed into something robust. Okay, so inside our buffer allocator here, we will get resource. Get the size, get num allocs, which will return our current buffer index here. Because well, the problem is that we override the buffer whenever we create the other resources due to the way the code is structured. So let me just close some of this inside our renderer here. Our I is actually used to offset into the buffer, which is not correct. I'm thinking that this should be changed to the constant buffer index here. Yeah, right now we don't need this function. Oh, and that's moved. Okay. So let's see. Unsigned int alloc index will be created like this. And then we will assign this to alloc index and we will use alloc index instead. Okay. Only our floor here is buggy then. +1, I think. Nope. Oh no, -1, of course. There we go. Because the first one will be 1. Or rather, would it? Let me just think a bit. Let's print this. Created alloc index. Because 1, 2, 3, 4, 5, which corresponds to our static objects. Oh, wait a minute. No. This should be correct, I think. Oh, wait a minute. I changed it down here, didn't I? Yeah, I did. I need to change it back, of course. Well, everything should be fine now. Yeah. Okay, so now our first slot got allocated to the appropriate buffer. Yeah, so that part of the code was buggy. We fixed that. That's more robust. All right, so we upload our what do you call it? Orthographic matrix. And down here at the UI, we will do a command, get graphics list, set root constant buffer view, and we will set the root parameter of 0 to our static get GPU address. There we go. So now we bind our orthographic thingy to our renderer. Whoops. No root signature has been set, so setting a CBV. Okay. Well, that might be right. Oh, wait a minute. Well, that doesn't make any sense, does it? Because oh, compute. Okay. That's why. It was staring me right at the face. You know how that is. Anyway, we have uploaded our data. Okay, so I think that we should start doing the actual rectangles themselves, since they are fairly easy to manipulate. So build primitive. We will simply change this, and then our text will be rendered like we used to until we change the shader, so we can see the effect. So this should make all our rectangles appear messy. All right, and we will simply type in our position X, our position Y, our width, our height, and our color here. So as you can see, this gets way more easy whenever we let the GPU do whatever we want to do in terms of calculations. We don't even need these parameters anymore because they're stored in our orthographic matrix. So this should make our UI look really weird. At least not weird, but no boxes appear anywhere. But that's intentional because we will now change the shader here. All right. Let's see. Float for instance position will be our, let's do a comment here and store our old code in case we need it. So we will, well, this will be our new position. So for each, oh, wait a minute, I actually, no. I think this is supposed to be like that. We'll see. All right. And let's do output plus CS equal multiply our pass data constant buffer transform our instance position here. Let's see if this actually works. Nothing gets rendered, but that's quite all right. And let's debug that. Thank you for dropping by, Rengoku. And thanks for hanging out with me. Hope to see you soon. Okay. So inside our UI here, we will upload our width and height to these positions here. And we will try to transform them. I think I might need to flip the yeah, I think I need to flip the component of the matrix here. Let's close this. We don't need that. This one. Still nothing. Mm. Oh. Mm. And this one should also be negative, right? Uh, yeah, I think so. There we go. Great stuff. So now we're back. And as you can see, we simplified our CPU code. Actually, we could remove the abstraction. Right now, it's just copying values. We could even simplify the UI by creating these values directly. But as you can see, hiding it behind a implementation is sometimes useful when you want to change the whole way that this kind of stuff works. Okay. So basically, we want to do the same thing for the text itself. Since we now use the transformation into orthographic view, we change the view space into a orthographic view that corresponds to our viewport, which is our entire screen. So we don't need to make the CPU do weird calculations, and this will especially be faster since right now the CPU has to do it for a lot of different characters. I mean, all of this could basically be removed. So let's see inside our font loader here. We parse the header, we extract the U and oh, it's no problem. You basically compare if the mouse position on the click is inside the minimum and maximum of your NDC coordinates. If that makes sense. Well, you do it either way, only one of the ways. I mean, you can choose to translate your vertex data, which is NDC coordinates, into screen space and then compare it to the mouse coordinates in screen space. Or you could transform the mouse data or position into NDC coordinates and then compare that to your vertex data. But you only do one of the things. But as I've mentioned, I think creating everything in screen space coordinates and then creating an algorithm that translates into NDC coordinates is the easiest way. Basically, it's what I've done. I just instructed the shader in this episode here to do the calculations for me. Yeah, but if you um, if you do, yeah, I shouldn't tell you what to do, but yeah, I definitely have an opinion on what's the easiest for you long term. We might need to flip this depending on the vertex winding order. Okay, so inside our rendering function here, we calculate the UV coordinates from our sheet height. Now we want to change this value so that the U and V gets pre-calculated. We don't need this anymore. We want to pre-calculate this. This doesn't need to be calculated anymore, it just needs to be subtracted. So inside our font loader here, our UV should be equal to this float divided by our, let's see, font data, where did we store it? Font result dot sheet width, our result sheet height, our result sheet width, and our result sheet height. The X, Y offset is fine. AD advance is fine. Let's see our font character. Great stuff. We only store that information. Maybe a scaling factor. We don't need that. Whoops. So now our font loader basically pre-caches this information. So inside this part of the algorithm, let's just do it as we did before. Whoops. All right. We don't need to do this anymore. Let's see our pos X here, our pos Y here. We will X offset, Y offset. Okay, we might want to actually store multiple instances of data. We want the U and V, of course. We want the UV width and height, but we might want a field here, float width, We could not. We could do something else than floats actually. But yeah, okay. This is not at runtime, so well, we are storing floats anyway, so we might as well, I guess. Float width, float height, because UV height, and UV height. So character dot height equals this, and this equals character divided by that. Width and UV height. And let's do the same thing here. All right, so this is not at runtime, so it gets pre-computed. We don't need to adjust that on the fly. We can simply pre-cache it. It's only 2 floats in memory, meaning that we can ask for the, let's see, width in pixels and the height in pixels. And let's do the UV. CUV height. UV height, of course. There we go. Wait a minute. We of course want our X and Y here to be, whoops, our position X and our position Y, in case we want to do multi-line rendering. So we replace this by X and Y. All right, let's see if this works or if we need to make adjustments. Well, it does work, but it turns out that our scaling is pretty weird. The text does look better. So this was probably the problem I had yesterday. Anyway. Let's see if everything is correct. Doesn't matter. I think the text is in the correct scale, at least because the font is actually bigger than was previously shown. And right now we can't trust the way that everything is rendered. Let's see inside the shader itself. Not the vertex shader, or rather pixel shader. I changed the pixel shader yesterday. Let's see. Does this? Oh, that flips it. Okay. All right. So let's try adjusting the size. Okay. I probably think that this should be maybe a plus, but not sure. Yeah, that looks way better. Way, way better. It's still way too big, but it looks better. Also, the interpolation between the pixels are now up to the shader itself and not the CPU. So probably, hopefully, we should get around any stupid rounding errors. Um, yeah, so let's compare to the text size that we actually have created in here. Small here, 30. So if we compare that to our screen text size here, it does seem fairly one-to-one, right? Yeah, it looks highly similar. So that means that now with this system in place, we can trust um, our hero output here. So let's see, let's scale down maybe to something like that, maybe. Okay. And let's save the file here. And let's recreate the texture. And let's not generate the MIPS. Let's create some high quality texture here. And let's try reloading. Okay. I do think the text does look better. Let's try removing that for now. That looks okay. Yeah, and inside our UI here, I think it's time that we stop using the thing here. We also probably should remove this. Let's see. Okay. Create render data. That's fine. Let's see how that looks. All right, we're back in business. Everything looks and behaves better. Great stuff. Great stuff. So that's basically also saving us some computations and some headaches in terms of mapping our text to our screen. It's definitely a improvement, and I can barely notice that we are probably around back to around 5,000 frames per second on some frames. At least we got a bit more performance out of the system this way because we don't need to do any weird calculations. We simply do pre-calculations. Yeah, everything just seems to work way better. Way better. No, if you just pass them directly, I mean, your vertices are in NDC coordinates, right? I mean, if you actually got a rectangle rendering on your screen, you don't need to change the I remember you posting some negative uh, values, but if it's actually rendering when you create the vertices, why change it? I mean, I really don't follow. Yeah, maybe OpenGL can guide you. Maybe OpenGL you can teach him to make a rectangle in screen space coordinates and render it to the screen. You can use the Discord server if you want to. I can even create a chat room for you if you want. I wasn't blaming you if that was what you meant. I know it's hard, man. It's usually on your profile somewhere. I have your ID if you want me to post it, but otherwise you both can join my Discord server and um, use the chat room number one. Okay. And yeah, I just wanted to be certain that I'm not blaming you for the struggles. change of coordinate systems are hard work. All right. You're doing great, buddy. It must be, yeah, I'm impressed by your work ethics. All right. So now I have implemented the GPU-based rendering of the text and the rectangles. Uh, as promised and suggested by the guy I look into. So that's great. We have saved a whole dozen of CPU cycles that way because we don't need to compute the uh, font information for each character anymore. We simply just pre-compute it at load time instead of at runtime, and we pass it along to the shader. Thank you, man. I try to do as good as I can. I'm not sure that I'm always doing the right thing, but at least I try. We could skip this. For now, we don't use the padding as well, so let's skip that as well. Um, yeah, what is SDF? I really don't know that one. Here is a chat you can use if you want to. Uh, Let me Google that. SDF. Uh, Signed distance font. Ah, okay. Yeah, I can imagine. I can imagine. Wow, that sounds interesting. Is it for OpenGL or? Yeah, it definitely looks way better at the distance. I mean, yeah, way sharper. Well, so it uses the alpha channel to clip out uh, bad pixels. That's interesting. I've never used DirectX 11. Yeah, they are great APIs. I just wanted to use DirectX 12. Also, I want to do a multi-threading engine, so therefore, yeah, I chose to use DirectX 12. Hello, both coding stuff and um, I hope I don't butcher your name. I'm sorry if I do. Singe? Yeah, coding stuff. I enjoy building everything from scratch, meaning that I can figure out where different optimizations uh, can be made, and also I learn a lot about um, API architectures. Oh, thank you very much. Thank you. That means a lot. I'm just an amateur, you know. Yeah, I never used DirectX TK. I use DirectX Math. Sometimes I do it in my tutorial videos. I use DirectX Math for that one, but never DirectX TK. DirectX TK, yeah, there wouldn't be too much benefit this far into the project anyway. Um, and besides, I want to do all the graphics pipeline stuff myself, so in the future, I'll do a 100% multi-threaded rendering environment uh, with a thread pool and scheduler. Um, I've done thread pools and scheduling before, so yeah, I might show it on the stream. It's a complicated but fun project. That's also the reason why I use DirectX 12. I want to be able to do CPU-sided work that is multi-threaded. Yeah, yeah, it's definitely from scratch. Even some of the math, or most of the math functions are implemented from scratch. Sometimes I have to look up the formula for different stuff around the internet. All right. Um, Coding stuff, if you're still here, I hope that answers your question. I'm not sure I have a completely rational explanation for why I do this on hard mode, but yeah, I've only been using 3.5 months of my spare time doing this project, and I already have a level editor with rendering and a UI, and yeah, I think things are going quite all right, even though I'm taking the slow route. And if someone asked me whether I could recommend it, I'd definitely say it depends on what you want to do. If you just like building stuff and understanding how things work, well, um, well, I've been working on this specific project for uh, the 3.5 months in my spare time. Um, Beyond that, I've done a bit of playing around with Unreal and Unity, but I think you could, yeah, it's been a fraction of what amount of the amount of hours I've used for this project. I also did a renderer in DirectX12 before I started this project from scratch, so I did have experience with DirectX12 before. But I've been doing other projects, so I've programmed also AI algorithms from scratch, implementing research papers and so forth. Also in my spare time, and I've done different applications for my own needs, apps and a bit of web development. So yeah, I've been all around different stuff. Back in the day, I did a bit of um, UI design in terms of web development and so forth. So yeah, but I imagine this project would kill most people. You have to really want to learn how to do almost everything. I mean, the UI almost killed me. I mean, yeah, at one point when I refactored the UI and started researching how to redo it, I really didn't want to work anymore on it, but here we are. And we're not that far from something that is, yeah, fairly sufficient to what this application needs. How about you guys? I know there are some very experienced people dropping by the channel from time to time. Let's see. We actually did a bit of this. We did that. Yeah, we need to fix this. This is also done. We will easily fix this one. Uh, and let's see how much cleanup we need here. Yeah. Well, from what I've seen, you're pretty good. No, no, no. My font is set up, let me see, like this. So A font is like a data collection of different values. So it has the size, a line height, the total number of characters, and then the texture height and width. Well, you're way better than I was at your age. So, and then we allocate a vector of characters, which are these ones here. And in my application, I simply create a shared pointer to a font. Oh, I should commit my changes. UI rendering, whoops, caps. All right. So I actually achieved most of the goals for this episode. The last thing we could do is something like, if I should do any more today, I might call it a day because it's been a long day at work. Mm. Okay, but basically I want to create either a version of our text fields here that are, and I also need to fix this as you might see in the background, we have a temporary warning here. But now that looks weird. I want these text fields here to be on the same line potentially, meaning that yeah, you can stack them, for instance, in terms of creating a series of coordinates x, y, z for the object, a list of rotations and so forth. So yeah, I want to do that. Basically, we manipulate the draw cursor of the UI. So whenever we register um, a um, a UI element here, we do recalculate draw cursor on the window, which basically updates the cursor. But if we want to stay on the same line, we need to not offset this, but instead just use the old value. We could give this a function or rather, we could do a maximum or minimum or whatever. We could do a minimum and set a, for instance, if we created a parameter here, we could do something like const float line change maybe, and then set it to float max, and then whenever we could do a check whether the line height or which were smaller of the line height and the line change. And if we set this to, for instance, 0, we could add that 0 to this instead, and we wouldn't change the line. Yeah, so that's a possibility. I'm pretty sure I'll yeah, that's a possibility. We could also just nullify this component here, but then we want it to, yeah, that's not great, because this shifts the draw cursor itself for the underlying window, meaning that it draws the content on a per pixel basis, potentially. Yeah, so we wouldn't mind adding 0 to the Y position, but then we would need to shift the X position. Yeah, I think I'm gonna contemplate that for tomorrow. Yeah, it's been a nice rework of the text and UI API here. Yeah, I'm definitely pleased with these changes. So did the link that I sent you guys for the private chat or for the channel not work, or because you can always use that if you need to chat or do stuff. You could also add each other as friends through the Discord server, so feel free to use it as you want. I can post the link again if you want. All right. Let me just hide the Discord messages here. So that I don't end up streaming that part. All right, guys. Any last comments for today's stream? Anything you want to discuss? Because I'm shutting down the stream in approximately 15 minutes for today. I'll be back probably tomorrow where yeah, I need to go do some cooking and maybe hang out with the missus. So, I've also achieved most of my goals for today, so that's really great. I think I'll be done with most of the level editor during the weekend. So finally we can move on to something else. A lot of you guys have requested something rendering related, so we should do that. Thank you, buddy. Thank you, buddy. I hope your project works out and everything gets sorted. All right, it doesn't seem like anyone wants to discuss anything or yeah, anything of the like. So I think all there's left to say is all that is left to say is thank you to everyone who dropped by the stream. Uh, it's always a pleasure to meet the new people and have different discussions. Um, if you found any of my content helpful, no worries, buddy. It's just good to have you here. So, if anyone finds this content helpful, entertaining, inspirational, or just likes a place to hang out, feel free to comment, like, or subscribe. I'll do more streaming over the weekend where I'll hopefully be done with this level editor. Let's see, what do we have of different goals? Well, we need some more nice features for the UI, but those are not mandatory. We need some more cleanup and a few bugs, and then we need items to be on the same line. For instance, group X, Y, Z editing uh, on the same line, line. There we go. And our level editor, of course, needs to have some kind of way of translating XYZ components, um, scale and rotation into a transform matrix. Since we already implemented add, update, and remove static objects, all we need to do is provide an interface where we can provide coordinates, scale and rotation, and then by the press of a button, calculate the matrix. Yeah. And then I think probably a gizmo of some sort where it would be a nice, interesting project to work on. For instance, this would be a gizmo, the one that you can drag and drop with right here in Blender. Some sort of simple gizmo that allows us to move objects around in the world. I don't think I'll add rotation for now, but maybe. Um, but that would be really nice. And then we would need save and loading. And then we would have a really, really simple level editor. Then in the future, we could add material editing and texture editing, but we could also just um, load them manually and store a register. For now, I think these are something that require some additional UI elements. This would require texture previews, and this would require um, material previews. Um, yeah, and this would require a dialog box for file path finding. Yeah, lots of stuff. But yeah, I'll probably save this for future work, and I'll just focus on these things here. Um, and then I recall, let's see, let's see. Um, as far as I remember, the vote is tied, but for a long time. Uh, maybe I don't think I've done saving and loading before, so it shouldn't take it shouldn't take that long. We will do a simple version, and we can always upgrade it and change it. Um, but yeah, I've done saving to file and writing different file output in different applications, so it should be fairly okay. It might not be optimal, but yeah, it should be possible. Anyway, I think the different rendering effects got the most votes. Someone within the last few days voted for the physics, but the rendering effects has long been the clear winner. Well, since you are a long-term supporter of this channel, I'll probably end up sending you the source code at some point or another. Yeah, it was funny yesterday when it wouldn't allow you to set the verdicts data. Um, let's do a simple version here. But inside here, I have the general episode plan. Let's see. It's not down here. Here we go. So this is our design document. We need, when we have a level editor, we need a design document where we specify um, how large sizes are we going to use in our world. And then I have planned on doing shadow mapping, because we do not have any shadows and it would be interesting to implement shadow mapping. And then we will do some game mechanics. Because when we have shadows, lights, and 3D models, and we can save and load levels, I think we should start doing some gameplay. Of course, I need to fix, or rather, make the physics stable, robust enough to scale, because the physics work was me. Well, it's basically the same. I mean, it depends on efficiency sometimes. If you need to do addition to do a check before you can do the check, it's not as fast as just doing the check, if you know what I mean. So for a lot of collision and clipping detection, minimum and maximum are the preferred values, which means that the the position and the width and height wouldn't give you the minimum and maximum directly. You would have to compute it every time. So sometimes it's better to store the minimum and maximum values. That's also why on a bounding box you store um, some different information depending on which um, um, storage is. Well, yeah, but instead, in some collision detection algorithms, I only do a simple if statement, and I don't have to compute. So well, I guess some places you could um, do either. Um, oh, this is not needed actually, is it? But yeah, it depends on what you're trying to do, I guess, and what you prefer overall in your application to be accessible, because you can't waste memory on both storing the X, Y, width, and height, and then also the minimum and maximum. Or you could, but I think that would be somewhat wasteful. So it would really depend on what you're trying to do. Sometimes your suggestion is the better one. Other times I think the minimum and maximum is the better one, at least for clipping. Yeah, maybe. Yeah, a simple inventory could probably be a great thing, but yeah, we can try out different stuff. I mean, the game mechanics section here is pretty open, so if we want to try stuff, or some of you guys are curious about something, we can try it out. But yeah, We'll go wherever the interest leads us. Cars? Oh man. That's a lot of work in terms of the physics. Yeah, cars are definitely not a easy thing to do, so yeah, for now I'm gonna pass on that one. Anyway, boys, I'm gonna, yeah, that could probably be done, but we'll start with something interesting. Real gameplay mechanics. Anyway, I'm gonna end the stream here. Thanks for watching. Thanks for hanging out. It's always, as always, it's been a pleasure. Um, remember to treat yourselves nicely. Oh, thank you, man. But as I've mentioned, I prefer to do things without help. So, and I also have a idea on how to do character animation. So it should be no problem uh, for me to implement. But thanks anyway. Thanks for your support and see you guys around.